Hey, Aaron, how's it going?
Good, Matt. How are you?
Pretty good. And welcome, Navi, to the stream. We've got a good episode for everyone today. Paul may or may not join us. He is on holidays. He's still keen to join. So hopefully we'll see him pop in any minute. But he's got, I think it was a plumber coming around fixing stuff.
More important
So
things to do.
So yeah, he hopefully that ends soon, and then he'll be able to join all of us on the regular stream. For everyone that's new to the show, we are Devs in the Shed. We stream weekly on the AWS channel as well as a YouTube, which we use for archiving in the majority. But our show is really about getting hands-on with development tools, and a lot of the times tinkering in the shed is something that we do, playing with little IoT projects. If you look at the background of my cabin, there's you can't see it the side, but there's a bunch of Raspberry Pis, soldering irons, and the likes. Paul gets into a bit more woodworking than me, and then Aaron he gets really into his bikes. So, anyways, let us know where you're all joining from. We're excited for today's session. Let us know where you are. We're all based in Melbourne. Navi, are you in Melbourne as well?
Yes, I am.
Yep. Perfect. And I do have to call out. Originally, when we caught up last week, I thought you were a board game enthusiast and you played video games like Borderlands, and I can still see all that in the background. But do you wanna give us a little bit about that?
Yes, sure. So, welcome everyone. I'm Navi Kaur. I actually work as a senior technical trainer here. Happy to be here. My stuff at the back is actually from my son's collection. It's nothing to do with me. So, first time when Matt asked me what Borderlands, and I was saying, "What do you mean? What is that?" Didn't even know that's called. It's from the game Borderlands.
Nice, yeah. I've played hundreds of hours of Borderlands on my Steam, so it's one of my favorite games. But it sounds like your son has really good taste, and I can see Ticket to Ride. So that Ticket to Ride game that's underneath your Borderlands statue. My sister no longer plays that board game with me because we had that much of a divide when I won because I double lapped her in that last time I played that board game. And the one underneath that is that Pandemic.
Yes. Yeah, especially
Yeah,
for the COVID times.
Perfect for the last couple of years. Yep.
Exactly.
yeah. So Pandemic, we played during the pandemic, and that was pretty fun. And I've got all the seasons of it now as well because they released multiple seasons, so you could kind of play through and the story altered for each month. So that was a lot of fun. But anyways, we're
I,
not here to talk about board games and video games. We are here to talk about a security first approach with serverless. Is that right, Navi? Do you want to
Yes.
lead us through kind of like what you have in store for us today?
Sure. So we'll be looking at one of the core serverless services called Amazon API Gateway, one of my favorites as well, through the security lens. How to make sure we are using the right features, which it provides a lot of features, which we can use to make sure all our HTTP APIs, REST APIs, WebSockets, they're all secure. So, yeah, we'll look into each feature one by one. I've got a lot of demos for you as well.
Nice. That sounds pretty good. What's the best way to get started? You reckon? Do you want to
Like,
walk us
I'll
through? Yep.
Yeah, I'll take you through the API gateway first of all. So this is a beginner session as well as for more advanced users as well. So I'll start with very basic as to how to create an API, what is an API actually, and then go and show the different features.
Cool. I'll pull up your screen then, so everyone should be able to see it now. And
Okay, great.
welcome, Lepcho. I can see he's watching us here. So he's an old
Great.
colleague. And welcome everyone from the US.
So Amazon API Gateway. Many developers are using API gateways scalable. It is elastic, scalable, and a managed service. So most of the stuff behind the Amazon API gateway infrastructure and all is managed by Amazon. So that means sometimes we overlook how we can also secure our APIs. And let's start by creating an API. So I'm going to build a simple API first to explain what it is, and then we'll
Hmm.
go dive. I can see on the screen when I try to create an API that there are lots of choices available. We have HTTP APIs, low latency, very cost effective, and WebSocket API is mainly for where you want a client and server to have that connection, ongoing connection, like for chat applications. That's where these are used. And we have our good old friend REST APIs here as well. REST APIs have lots of features which are still missing from HTTP. So that's why these are mainly used for where you need to have your backend as Lambda function or different other AWS services. So I'm just going to build a REST API quickly for you. So clicking on build.
Are you going to touch on the difference between REST API and REST API private at all? Otherwise,
Uh,
I'll jump in and.
when I No, I will do that when I show you the different endpoints.
Awesome.
Yeah.
Awesome.
All right, so we are creating our first API in this particular North California region, and it gives me an example to start with to say we have an example API ready for you with all the different configurations. Do you just want to choose that, or do you want to create your own? Let me create my own. So I'm just going to call it demo, give it a description. Later on in the show, we'll be looking at these endpoint types as well. So there are a few choices. We'll go through each one of them. I'll leave it at regional for now. So I'm creating an API where I want my end users to get something from a backend. I want my backend to be very secure. I don't want to expose that to the user. So I'm just going to go and create a URL for them to get a response from the backend. I'm choosing the method get. And here it's asking me, what is your backend? What integration type would you like to choose? I can have a Lambda function doing a business logic. I can even have an HTTP end, which is nothing to do with AWS. It is something maybe in the legacy world or in the data center you have a server set up. Or I can choose one of the AWS services. And here is a big list of which AWS service can act as a backend. My favorite is DynamoDB table. So if I go DynamoDB, I can set up DynamoDB as a direct integration with my HTTP or with my API as well. So this is a way we set it up, and then it gives us a URL as well. At the moment, I'll just do a mock one. I don't want a backend integration because, as I said, I want to show you the features of API Gateway itself. So just do a mock to say what things can we do within the API Gateway to make it more secure, to do other stuff like validation, authorization, etc. So my API is built. I can do a test here. But before even that, I'll show you a few things we can do here. So end user wants to get some response. I don't want to send that request to my backend as yet. What I can do to make sure there are no SQL injections, there's no stuff they are entering which is not validated, I want to validate my request. So up here, if there is a request validator built in, I can choose how I want this request to be validated. So a lot of things I can do before the request has gone to the backend, or even when the backend is providing me a response, before that response goes back to my end user, I can change the format, assign a different header, and transform it before the response is provided at this API gateway level. So what I'm going to show you first of all is how to validate the request body. All right, going to one of my APIs, which I've built in advance. What I've done here, in this API, on the left-hand side, I'm going down to models section. I have built in a model where when the user is providing any details, I want API to go through those and make sure they are the ones, it validates it before sending it to the backend. In this case, the backend is a DynamoDB table, and you might know that DynamoDB is NoSQL. So schema is dynamic. It will take whatever someone inputs in it. So I don't want that. So here I've got some properties, name. The name end user provides has to be a string. Minimum length is 3 characters. And then when they're providing the age for this application, it has to be integer, and it can be only above 18 years. So I don't want any children to go and get stuff from this DynamoDB table or post something in this application. The required parameter here is age. So let's see how this works now. Going back to the resource, I have made sure in the method request section, it validates the body as per the model name, which is user input. So I can do a test in the API gateway itself, or I can use one of my favorite testing tool called Postman. So Postman this is like when I created the test, I can give it to a tester team to say, can you please validate and see if it works? Can you test it out? So I'm just going to go to this request here. This is the API, HTTP API URL, and I'll send a post request. If in the body, if I provide the age above 18 and a name, it comes up and says all good. But if there's a child who is trying to play this game, which they can't, and they are only 13, they are sending their information, the model checks it and says, no, this is invalid. So at this validation, we can inspect, we can filter, we can enrich the data we are receiving from end user. So age was a required parameter. If the age is not provided, so I'm just taking it out from the test, and then I send that command. It'll again says, now please provide the correct input. So really good security mechanism. My backend will not be even triggered. No one can put the information in the DynamoDB table unless it is validated at method request level.
Nice. We did have a few questions, so I wanted to stop on this particular screen. But GoGuppy mentioned that he'd like to understand a bit more about the terminology that we use in API Gateway. So, what's the difference between request, response? What's the difference between proxy, non-proxy, base mapping, and the last thing that he did add was AWS function URLs. So I don't know who wants to have a go at these, but yep.
Yeah, that's okay. I've got the screen in front of it. I can explain. So
Cool.
what basically is happening with the API is end user could be a mobile application, web application who is triggering the URL. When the API gateway receives that URL, that is like a request they're receiving, so that the backend can provide some information, or in this case, the DynamoDB is going to go updated. If I provide the right input, it is going to add that information into the backend. So here I'm doing a test, and now it takes the request. This is the request, and it goes and puts in the DynamoDB, and this is the response here on the right hand side. The response is provided to say, yes, all good, DynamoDB is updated. It could be anything which a developer builds in. So that's what it means by here. Before sending the request to the backend, we can validate it. We can use authorization, which I'll be showing you next. We can integrate the request to say which DynamoDB table. There is no mention of the DynamoDB table in the request. It was only name and age. So here we can enter what is going to happen when the request is passed to the DynamoDB table. The DynamoDB table name is also supplied at that point. So this is where I'm taking the request, sending it to update database DynamoDB table, and it updates it, and then it provides a response. And I can show that response to my end user by giving it a sentence to say DynamoDB has been updated, or some kind of other response, which is where I can make changes as well to that response before it goes to the end user. And if this is ready to go to production, I can deploy it to production stage, QA stage, test stage, and that's when I'm going to get a URL. So when I'm just going to deploy it to one of the stages here, and now it'll give me a URL. So I hope that's the URL you were asking about. This is the URL API Gateway creates when I deploy it. And was there one more part to that question, Matt?
Yeah, the other question was around like proxy and non-proxy integration.
Yep, sure.
Yep.
All right. So when we look at some of the examples, it'll be clear. Usually when we talk about proxy, it is about Lambda function. We are just using API Gateway to pass the information to Lambda, and Lambda does the business logic. It updates the DynamoDB table. It can go and put information into RDS. So most people use Lambda to transport, which is why we actually want as part of the best practice, Lambda should be used to transform, not transport. If you are just putting information in DynamoDB table, you can simply integrate with the AWS service directly, like I have done in this case, the DynamoDB table. So not
Yep.
using Lambda as proxy here.
Yeah, and like if we had a Lambda specific situation, like I think the way that I've thought about it, but I'd like to hear from everyone else, is generally most like API gateway to Lambda solutions that I've built in the past has always basically had API gateway straight out proxy the request to Lambda, and then Lambda does the transformation and whatever all the else, all the other things are. It's all performed within that. Whereas, like, my understanding of like the proxy mode is when there can be transformation done on API gateway before it goes to Lambda. I don't know if I've got that correct or not, but I thought I'd put it out to the group.
Okay.
Yeah.
Pretty much yeah.
No, you go, Paul.
Yeah. So, like, if you're proxying directly across, you're not doing any sort of manipulation on the payload as it's coming through. You're not doing any type of validation. You're not validating the model or anything like that. You're relying on Lambda to take care of all of that. Whereas if you use API Gateway, I would guess to its fullest extent, you start to inherit a lot of protecting invocation of your Lambda function when it doesn't necessarily need to happen. So you're putting more of that responsibility back onto API Gateway to say, you take care of like getting the data across, and my function can rely on what's coming through to be correctly formatted, the correct model within the specifications that you've designed for as well. So it can help separate those concerns out.
So the two biggest areas where I see the difference between creating a REST API and then also a HTTP proxy to Lambda, actually three. So the two that I see would be in line with what Navi was saying around, if I'm just sending data, then there's no point in doing a proxy to a Lambda if I can write directly to DynamoDB, because I can also handle my validation. I can handle everything through the API gateway. There's a no-code way of doing things. So the two here are the differences between a no-code and a low-code, or a no-code and a code type situation. The other one is, if you remember back a couple of to our last episode, where I did the microsegment around using .NET Web API as a serverless HTTP proxy Lambda. That way, I can actually take all of my existing application architecture. So I've got all of my controllers, I've got all of my endpoints, I've got all of my routing, I've got all my model validation already in the application. There's no point in me actually going and rebuilding it all in API Gateway to handle each of the resources that the controllers are handling anyway. So that's the other one. And then the third is, if you're starting from scratch, a lot of the time when I start a new project, I validate, back to Navi's point again, am I just handing stuff in to a single service, or am I wanting to do something in a way similar to what we do with AppSync and talk to multiple services? If I'm doing some chained logic and saying, I need to talk to DynamoDB, and I need to talk to AWS config, and I need to talk to a couple of different things all in one request, then I'll use a Lambda to do that. Because otherwise, doing it through API Gateway would be set up a resource for sending to the DynamoDB. Then it would be very chatty. Set up another one, a request for talking to config, then set up another one for talking to whatever. So it becomes a chatty interface where all of the logic's handled on the client side. So better to use an HTTP proxy to a Lambda, where you can use your business logic to talk to the different services that you need, if it's not just as simple as, to Navi's example, sending it directly to a DynamoDB. Because the strength in that is, if you're only using one service, now I don't have to code my validation. I don't have to code everything that I need to get from resource request all the way through to response.
Mm-hmm.
So there was one other thing, and that was the base path mapping, I think. That was the last thing that was mentioned, which is fairly, I think that one's fairly straightforward from my experience, and that's just basically the base path of what you're going to call to your whatever you've built in the background. So if you've built an application for, how do I explain this? You go, Navi.
I might be showing. I might be showing it in my examples anyway. So I just did a basic API with the method, but we can have resources as well, which will change the base path URL. So this example, while I'm showing the examples, it'll be clear, because those are some things which are basic, but when you're building and trying out, developing different things, those you can understand easily. So with this example here, I'm going to now make sure the URL, whenever someone hits it, I want to check if they're authorized or not. So when I'm receiving the request from the end user, I can also build in authorization. API Gateway itself does not have any authorization mechanism. It doesn't provide tokens, but we can use different other services. Like in this case, when I want to hit my customer's base path URL for posting something, I want to make sure this user exists in the user directory incognito. Cognito, if you haven't heard about this service, it's a cloud native user directory. It can be used for sign up, sign in processes for different applications. And I have created one pool already where I have got these users who have signed up for my application. And these are the only valid users who can hit that URL to get the information or post the information to the backend. And what happens is when they try to use, so I'm just going to be one of those users, and this here, I'm going to get a token first. So I am trying to go through, let me just clear it up. To get the token and provide my user ID and password in clear. And this is going to go to Cognito first, get the token. The token is then supplied to API Gateway, and then API Gateway is going to validate the token against the Cognito service and let the user post the information. So here's my token. I'm going to use that token to post the information by going to Postman, bringing it up. So that is expecting the token. Without the token, it's not going to give me any information. So if I send it without the token, the API gateway says, no, your token, either it has been expired or not working, please provide the token. I'm just going to make sure here it has no spaces around it. Doesn't, that's good. So when the token is supplied, the URL provide the response back. So this is another way of authorization we can use. There are multiple other ways we can use. If someone wants to have a custom authorizer, they can build in their own logic. They have an Active Directory, they don't have Cognito user pool, they can use Lambda authorizer as well. So in this Lambda authorizer case, the Lambda is going to go and validate according to an IAM policy, or they can go and check the Active Directory, Azure Active Directory, any other OAuth provider, and come back and say, yes, this user is valid or not. So let me show you this example as well. And these authorizers are on the left-hand side. When we're creating the API gateway, we have to set up the authorizer first. I have the Lambda authorizer in this case here. I can do a test within the API gateway as well as via the, so I'm going to just provide a token header in this case. And it comes back and tells me if my request is denied or allowed. So if I provide the right token, what it is expecting, not a secret, it will then give me and permission to say, yes, this is the right token you have, allow. So I can tell my end users to use that as an authorization token in the header, and only then it will be validated. I can even cache the authorization so that they don't have to do it in each time. And I can say this caching will be valid for like 20 minutes or so. Once the authorizer is set up, it has to be included in the method request section. So we're doing a lot of things in the method request, but the others are useful as well for filtering, inspecting, and other stuff, like formatting the body. So again, here in the authorization, it's not IAM, it's not Cognito. This time it is a custom authorizer. So you can have any business logic to check if the user is valid or not. And when we were talking about the path, so most of I only got, these are demo API gateways URLs I've set up, right? So it's not like in the production. Usually in the production, you'll have different resources, different paths, different methods. So that is very useful. In one of the examples later on, we'll see them as well. Another authentication way is to use IAM, especially for the developers who are working for the company. So IAM administrators, they can assign a policy to say which developer can hit which API gateway URL. And in this case, if they have access, only then they'll be able to hit. If they don't have access, it's denied, they won't be able to hit that URL. So that is set up in the IAM for internal users. So in this case, I've got two resources. So /dev for the developer to get something from the backend, and then /tester for the testers to get something. And they might have different policies. So in my Postman, what I have to do is use my access key and secret access key, set it up, and it's going to, so in the authorization, I've put in my secret access key and access key, if you know that is an IAM related thing. And then in the headers, Postman is going to use signature v version 4 SHA-256 technology to create an authorization token to send with the request. This token, this authorization token is automatically created if someone is using the SDK, AWS SDK. So here the developer provided the keys and it says, yes, you can start the development work. If they don't provide the key, then it won't work. So in here, the dev URL is fine. But if this developer with their own key is trying to hit the other URL, so this is the base path URL we were talking about. And if they don't have access, it's going to come back with that IAM policy to say, deny, you're not authorized to perform this action. So we can go as granular as we want. We can set up this policy on the get method, on the post method, delete put method differently, according to what the requirements are. So any questions on this, or if someone want to see the IAM policy?
I think Sean's just saying that, and it's probably rightly so, that understanding and having a really clear understanding of how to use and leverage IAM, requires like a PhD. And I think that there's look, there's some truth to that, right? Like it's running security and making sure you've got your workloads as secure as possible. It does take some effort to go in and do that. And I guess that's why like our security specialty exam is like a specialty exam, because it's difficult. It's going to go really deep to make sure that you're understanding what you're doing, what you're exposing. But at the same point, look, if you're building, a hobby website or something, you might provide quite a lot of open permissions. When you've got like, business critical functions that need, highly tailored and granular access and authorization policies, you have the ability to go and implement that.
Also, to the question that Sean raised around, is it a bearer token? We did respond, it doesn't have to be a bearer token, but I just call out that bearer is not a part of the token. Bearer is how it's being handed to the in the request, in the request header. So you can have different types of token types. The token itself, the bearer isn't part of that token, while it's part of the response for an auth header when you're doing a bearer token.
Mm-hmm. So this is IAM policy. I think there's a very good URL. The AWS documentation is great. It's excellent. Even when you're learning for the certification exam or doing real life production work, I got this policy from the documentation, right? So very clear, very granular, you can make it. So if it is set up, the only thing IAM administrator wants to allow to the developers, they can only do that much work. So two kind of policies. This is the invoke policy. There can be an access policy as well. Do they even have access to the API service itself? Okay, so that was about authentication. What about the most of the URLs are publicly available, right? Because I do want other people all around the world to hit them. It is they can use my services, but I am scared of, or I have to be security mindful of what happens when there's a DDoS attack, or layer 7 HTTP floods can occur as well. So our service called Web Application Firewall can be used in conjunction with API Gateway to make the URLs more secure. So Web Application Firewall is a security service to protect your web applications. As the name suggests, And you can integrate that with the API gateway as well. So I'm just going to go to the web application firewall, and it is a regional service. So I have an ACL created for the US East region, and I can associate it with multiple resources. In this case, I have associated it with the API gateway, one of the API gateway URL. You can create web application firewall for your CloudFront distributions, for application load balancers as well. This one is resource type API gateway. So people are hitting my API. I can see a sampled request on this WAF dashboard as well. So this is what's going on with my API. Sometimes it's really quiet, sometimes it's busy, but I don't want HTTP flood rate. So here it's showing at the services, it's allowing everything. So let's do a little test here. Using the Cloud9 IDE, Cloud9 is really great. I love it. You don't have to install any agents like Visual Code and PyCharm and all that. You can simply use Cloud9 from any browser. There is an EC2 running behind it though. So what I'm going to do here is to say, my application, everyone loves it. It's the next Pokemon Go 2 or 3, I can call it. So there is 10 users trying to hit it 2000 times. So the same IP address the request is coming from. And my WAF has been set up with a rule to say there is a rate-based rule. If someone is hitting them more than 100 times in a second, you need to stop that and put that in. I'm just going to open up another column here, and it's going to stop them from invoking them. So currently the artillery is running, it is faking those requests, and on the right hand side I'm just saying, can I go to that URL anymore? And it says no. There's no response from the backend because the WAF has blocked it. But if I do the same thing from my another IP address from the postman, the same URL has no issues. I can still get a response from them. It goes back and comes back and tell me what my favorite services are. So you can also hit that URL from your IP address. We can put that in the chat if you like to hit it. But this IP address here is blocked. So if I go curl, give me my IP address, it's ending with 75.16. I come here and have a look at the sample request, and just the ones which is HTTP flood rate based, looking at that, 75.16, it has blocked it. We can use bot control. So WAF is also very, very feature rich. I won't go into too much detail on what WAF can do, what it cannot do, but just showing you that it has the robot blocker as well. So bot request will be blocked. I can provide a custom response body, and that's what I was doing that. So if when it blocks it, it's going to provide an error. Sometimes it's forbidden. I don't like that kind. So I've changed it to say, cool down, go drink a glass of water, because I'm sure this is going to work in a while. So it is only going to block it for a few seconds, and then it'll bring back, and the response will be provided. There's a time period. And how is it set up is all in the rules. So certain rules are provided by AWS. AWS managed core rule sets. So for the bot control, you can have your own rules as well. You can have your own whitelist, block list. I'm using this HTTP flood rate based rule as well. And if you don't want to have your own whitelist, you can actually go and subscribe to a vendor as well. So these are the vendors through the marketplace, and they will update their list so that you get all the time you are getting the latest information according to what is going on in the world, how many malicious actors are out there. They update their list, so they'll do yours as well. I've got my own custom one set up. So in my Lambda section, there's a Lambda which is running we can run it every hour, every 10 minutes, based on how busy your application is and how much protection do you want from the bad actors. So this Lambda function here it checks that third party. I'll actually leave it on the description is in here. So it checks the third party IP reputation list every hour. I've set up an event bridge rule up here and adds the new IP ranges to the list. So that's the web application firewall. Any questions? Are we getting any questions on this?
There was quite a few questions about the load testing tool using Artillery.
Yeah.
Because like I haven't used Artillery, but I'm familiar with it because I know I have some of their swag and some of their stickers. I guess that's similar to what like Matt and I typically go to, which is Locust, to go ahead and build that. A couple of questions about Cloud9. Yes, there's a little cost to use Cloud9. Obviously, you're paying for the underlying compute. But Cloud9 will, you can specify specific machines. So depending on what you need, you might need like, look, if you're trying to compile a really large Java or C++ app or something, for example, you might want a lot of CPU. So it might end up being much cheaper than you expect because you're going to get it done, quicker. But it also has the ability to turn off after a period of time. So you're not paying for idle use. But I think it was like, I'm not quite sure, but about a year ago, we released our Cloud Shell. So if you were like for code with Sean, if you haven't seen that yet, so Navi's just hovered the mouse over the top of the Cloud Shell. So that's directly available within the console without having to go and spin up a whole IDE. And the Cloud Shell is really useful if you need to do, I don't know, some AWS CLI commands or install something like pretty quick. I think underneath it's just a container that's running. But it's really handy. You click a button and bang, you've got it. And you can upload files to it. And, if you need to do something quickly in a shell. So, it's just quicker than, even firing up your own terminal, like locally, if you don't want to install and mess up your local environment. But also if you didn't need a full IDE like Cloud9, it's a little bit quicker to go to as well. First click there, it takes a couple seconds to start up. The second one, it's done.
To give you an idea of the pricing on Cloud9, though, like I've got a couple of projects that are actually running in Cloud9. I use like a T2 micro. So it's small, but I always up the size from 10 gig to 20 gig. So I've got more storage. It's enough CPU to do CDK, to do web applications like React apps, React Native, with Expo, like the kind of stuff that we do on the show here. All the T2 micro is enough. It costs, I think at the end of the month, it's between $4 and $5 a month, Australian dollars. So it's like $3 US a month.
Yep.
But that's with your cost saving settings to turn off the instances within half an hour.
Exactly.
Right?
It is, yes.
Yeah.
So when I'm not using it, it's not running exactly.
Yes.
Yeah.
So it actually has an inbuilt mechanism where you can choose while building the Cloud9 EC2 to say, turn it off after 30 minutes if not in use.
Yeah.
So you don't have to go and do it all the time. It will automatically do that. So really powerful.
So that's about 90 to 100 hours, a month.
Yep.
Of actual usage.
The other thing that people ask a lot about with the cloud-based IDE, for anybody that's building front-end applications, you need to like look at the HTML that's being produced. So we know when we start up our application and we're like, npm run start or whatever, how do I invoke like remotely that endpoint? The Cloud9 has like a proxy service embedded in it, so that you can build like front-end applications, full React applications, and have hot reloading. It all just runs through your browser. It's all just really seamless. So it's really handy. It's a reasonably good alternative to developing locally.
Right, thank you for that. Okay, so this is where when we are setting up a production stage or QA stage, we can enable the web ACL. So usually people do it for production, of course. And we can also enable API cache and make sure that it is encrypted. So API cache is where the GET responses will be provided from the cache, not the backend won't be troubled for this, so it can relax. Basically, when it is important that we don't go and hit our backend all the time, we can use the cache. And the cache capacity you can set up from 0.5 gigabytes all the way up to 237 gigabytes. And suddenly, if there is a production problem or some kind of event has happened security-wise, you can even flush the entire cache with just a click of the button. So I'm just enabling the cache right now, but if it was already enabled, it will give me a special button to say flush the cache. I can use that to just delete everything from the cache. We can configure time to live there as well. We'll look at this throttling in a while with a different example. Now we are on this monitoring, very important. We're using WAF for that. We can also use CloudWatch monitoring service. And then there is X-Ray as well for distributed applications. So let's have a look at that example, see what CloudWatch, our monitoring service, can give us as far as API gateways are concerned. So I've got this nice example API, which has a lot of resources, a lot of methods. So it has a get, post, and then it has a resource called pets, and then a few more methods, another path. So all these paths have their own URLs. It's deployed to production. The get has a URL. If I want to know how many pets or the pet ID, the different URLs here. So let me just show you one. And this is again a public URL. It's open to the world. No authorization set up on this. It comes back with some information. Because it's open to the world, I want to know each and everything what's going on. I want to not just the execution logs, I want to enable the access logs as well. So going to the CloudWatch and first I'll go to the log groups. So every time someone is hitting that URL, it is going to get that information and put that in the CloudWatch access logs. And what I can do is either send these logs to another external system like Splunk to do some analysis work, or send it via the Kinesis Firehose to Kibana dashboard, or just run an SQL query within the CloudWatch as well. So CloudWatch is becoming very feature rich. It has its own tool, logs inside, and I can choose my log where I want to run the SQL query and do a lot of troubleshooting or analysis work within this logs inside. So this one is about the get method, where did it come from, which IP address, all that information can be collected here in this log group and seen from the login side. So these are the logs. But what about the metrics? Because I want to get all the metrics on how many people hit my cache, how many people hit my URL, what was the latency, what was the integration latency. So I can set up a dashboard, good for visualization. I know all the developers, they love this black color. Sometimes it's hard to see on my screen. So I change all the colors to light, but this one I left alone because it really looked good. On the left is my API gateway 400 errors. I want to know what kind of errors are coming up. Is it growing or decreasing or stable? Maybe I want to do something about it if there are too many 400 errors. I'm counting how many people are hitting my URL. I've got two of these from the WAF as well. So the blocked bot request or allowed request. And also this one here is a web application firewall, manage rules, anonymous list, block list, how many of them are hitting my URL. The two important ones here is the latency and integration latency. So there's a minor difference between these. Latency is when the request has been received by API gateway and the response has been provided, how long it took for the total round trip. That is the latency. Integration latency is API gateway itself is checking when I send the request to the backend, how quick it respond to me. I want to know that as well. So that one is built in here in the integration latency. We can set up alarms as well on any of the metrics here, just like we normally do for CloudWatch. And the X-ray. So X-ray is specifically for distributed applications where we have one request received from the end user, then it goes to the back end or it does something else. From there, it goes to another service. I want to see everything what's going on from one dashboard. So this is the X-ray dashboard here, which tells me that most requests were green, but there are some yellow as well. And if there's something especially wrong, it'll show me the red color as well. Now I want to go deep dive into these. So say what happened, why is it yellow, what is the error? On the right hand side you can see it says error is 39%. So can go deep dive into that, view the traces, analyze the traces just by clicking on it. It's going to tell me exactly where was the fault, what was happening. what was the HTTP status code, a lot of information here as well to go deep dive into each request. So I'll show you one trace. This one is 200 response, means all good. 403, something was wrong. I want to know what was wrong. What was the response? How milliseconds it took? What is the trace look like? And the error message. So deep dive using X-ray. Trace and analyze your user request.
So 403, that should be a forbidden request. It's not authorized.
Yes, it yeah. For this API, I just had a URL which was not well formed, and that's why the error. But yes, so if you enable trace on any of the APIs, X-ray on any of the APIs, it will give information according to that particular API.
And X-ray is not just for API Gateway. That will stitch itself through other specific services as well. I won't list them like now, but you can get a correlation ID between different services as your payload is moving around. So look, if you're putting a message on SQS and then you want to pop it off at the other end and have a look at where it's going to, X-ray can do that end-to-end tracing as well.
Yep, that's true. So all this time we have been looking at an API URL created by or given to you by the API gateway. It is HTTPS. So those URLs, when I get from here, after I deploy my API, the URL will look something like this. It is secure, but most of my customers don't want to see this ugly name. What they want is my company's name, a custom domain name. So what I can do is disable this URL and map it to a custom domain name. So in the settings, I have said the default endpoint is disabled. So even if the customers click on it, it's not going to work because I have disabled it. Instead of that, what I want is to use my company name, as I said. So I have to do and set up a custom domain name for that, which can be done easily. And here is the custom domain name, api.mycamerapics.com. I can do the API mapping. I've just done it for one of them for this picture domain. So now when my customers go to my website,
I'm getting myself distracted here, but I just for everyone in Australia, we released .au, so we don't need a .com.au URL. So it's like a new thing that we can buy on the cheap for URLs, which is kind of exciting. So I might be buying my name .au. Sidetracking myself there. It just reminded me. Last night I saw the ad on TV, and I'm like, like maybe I can snatch up some prime domains now that we have .au as an extension.
The other good thing about the custom domain names is because you can map it to a stage. So you can have like dev.myapi.com mapped to the dev stage and the production one mapped to another area as well. So yeah, that's really handy, but also you can like swap those around as well if you need to.
yes. And yeah, exactly. And then that means it won't, even if your API with the custom domain name, mainly it's about certificates as well as the reputation of the company. I will not go to any if NAB says just hit the URL, it's a different one. I won't trust that. I trust the company name. So that is important as well. But that is taking me into my next point, next demo. So when we go to a reputed bank site or some other government site, we don't have to authenticate to them, but we want them to show their certificate. But sometimes business to business applications, they actually want the client certificate to be a trustful certificate as well. So mutual trust is possible for the application where we want the client to provide a certificate, the server will check the client certificate, client will check the server certificate, and then this trust is built. So my next API actually has the mutual trust authentication done, where I can also choose what version of TLS I want to use for that. And I'm keeping the client certificate in my S3 bucket. That means this URL will not work without someone providing the certificate as well. So just going to mtls.mycamerapics.com, and it comes back and say, where's the certificate? If you don't give me the certificate, you can't come. So mutual trust, mainly for medical companies, or where there's a compliance, is regulated bodies, they check business to business certificate, mutual trust they build. So I need to
Well,
provide.
Marky and I worked for a bank, and I know the bank still use that quite a bit in the past. But also many of my customers, even in retail, use that as well. So MTLS is something that I guess like more people tend to favor like a OAuth, setting something up like that's a different type of authentication mechanism, but it's still very commonly used MTLS, and I guess hence why they went ahead and released this specific feature not that long ago.
Yep. And I'm just going to go and provide the certificate just to see. So give me a second. Okay, I'll bring my favorite Cloud9 back up here. So I have the certificate files from the client side. I'm a client now, and I'm providing that to say, I want to make a connection, give me a response. And when I provide the certificate, it's happy. It comes back with my favorite services. And if I don't provide the certificate or don't provide the right certificate, then it will not be able to verify me. So no trust with this particular client, and it'll reject the call. So that's something, another feature, mutual trust, if you want to build, just an extension of TLS, transport layer security. Okay, we're very close to finishing time. One last important API I want to show is, what if I want my application to be only used from my VPC? It has to be used only by the internal staff or employees or people in my data center, but I want to build it as a private API. That can be done easily by setting up a private API endpoint. So there are 3 endpoints. Going back to that, and when we were creating the API first time, I'll just go and show you those as well. So we can have edge optimized API, regional API. Edge optimized is for global users. You have users all around the world. You want them to hit your API with low latency. You provide an edge optimized API. Here, AWS is creating the CloudFront distribution on your behalf. So you don't have to worry about the CloudFront distribution. You don't have to worry about the security of that CloudFront distribution, because Amazon is taking care of that. But you can't use that CloudFront distribution as a cache. It is only for request and response. We have regional APIs where most of your calls are originating from the same region. This URL can still be used globally, but for the region, it will provide very low latency. And another benefit is you can set up your own CloudFront distribution. You can use it for caching as well. Plus, sometimes people want to run Lambda at edge. You might have heard of that. It's really a buzzword, Lambda at edge. So you can do some compute on the CloudFront location as well before it reaches your API. Sometimes due to compliance as well, you have to control your CloudFront distribution. You can use the regional endpoint and then set up your own CloudFront in front of it. The third one, where I was going to show you the example, is this private API, only accessible from the VPC, using the VPC endpoint, where you have a private connection. If you're using VPC peering, you can use this endpoint from multiple VPCs. If you have a direct connect or site-to-site VPN, managed VPN setup, you can use it from your data center as well. So with this private API, 2 things we have to do. First of all, choose the right endpoint, which is private, and then set up the resource policy, where it will say specifically that this endpoint is only available from the VPC endpoint. The resource policy is just like any other resource policies we have. You might have heard of bucket policies for S3. Similarly, API Gateway can have a resource policy as well. So this one says allow access to API. Principle is that AWS anything star, doesn't matter who is invoking it at this point. We can go granular if we want, as long as they follow this condition, which is string equals the VPC endpoint. So someone is using the VPC endpoint, fine, they can come and hit it. If they're not using the VPC endpoint, they won't be able to hit this URL. this resource policy can not necessarily we have to use it on the private API. You can use it for regional and other API endpoints as well. You can have an IP range deny list, or the cross account access can be given using this as well. So I'm just going to go to one of my EC2 machines from where I have set up this VPC endpoint to show you. Okay, just bringing it up. Okay, I think it realizes the time is up as well, so it's gone very slow. So I want to go and hit API Gateway Service, which is a public service. It's not something which I can control through VPC, but because of the VPC endpoint, I'm accessing it using private IPs. And now I want to hit that particular API URL as well. I'm curling the URL. This is the whole path. And it says, fine, I'll give you a response because you are coming from the VPC endpoint. Now, if I hit the same URL from anywhere else, from another machine or from my browser, it won't give me anything because it's a private API. All right, so it looks like, yeah, we have made the time as well. Are there any questions?
I really liked Jessenberry's question actually. What kind of AWS services do people use on the show? I thought that's a nice question to kind of finish up on, maybe potentially.
Yeah, be interesting to hear, I guess, from the audience what services they're most interested in and what they've been using. And what about you, Navi? Because like you're in a different internal area to like Matt and myself and Aaron. So what are you seeing a lot of people talk about and use?
Okay, so normally my students or my customers, they want to know about databases. DynamoDB is a favorite one. So is Lambda. So people feel like anywhere they can learn the theory and do some hands-on as well, that becomes like a favorite. Once you learn a few things, how you can do them, you start liking them. So DynamoDB is popular. Lambda, very popular as well.
Yep. Yeah, we got like SageMaker. So we've done sessions on SageMaker. We've never talked about Glue or Athena. So maybe that's something that we should get in the future. And we can go, because Yana B94 users interested in SageMaker, but they use a lot of Glue. I mean, look, we've been doing the show, Matt and I have been doing the show for, getting on a year now, and we've barely touched the surface of our services.
We only touched databases like a week ago, wasn't it?
Yeah. And so we
Dynamo,
had a bit
of
DynamoDB global tables.
Really deep. Yeah, we're planning to do a really deep DynamoDB session with one of the internal product team members. So that should be really good as well.
I've got the perfect person also to bring in as a guest for AIML if we want to look at SageMaker, and there's a lot of stuff that we can look at in that area.
And I was going to say my one's Amplify. I get paid every time I mention Amplify. Is what everyone always says.
Amplify.
Yeah, I really like Fault Injection Simulator as well. So, like we talked about load testing with Locust before. It's like, if you do a wine pairing with that, you've got to pair it with Fault Injection Simulator as well. They go well together. You can load test, and then you can, test the resilience of things within specific components of your app.
So a lot of what I use at the moment with my customers is a lot more of the serverless event-driven architecture. So API Gateway to Event Bridge to external HTTP APIs, to Lambdas, to DynamoDB, to basically all things serverless. I love this. I love what you've just demoed here, Navi, especially the private API, because this is very familiar to where I work in so much as a lot of the global integration solutions are very much account segregated applications where you'll have one account which handles like integration platform, and API Gateway is like the key to the integration platform. So you'll have like Transit Gateway, or you might have like a even VPC peering, but let's not go there. But you'll have like other accounts which have their private applications, which are then using API Gateway inside the integration account, which then integrates with either external services or on-premises services or other integration serverless services inside the integration account. That was great. I love it. So there's a lot that we can learn from you here in terms of securing it all.
Mm-hmm.
Yeah, I was going to say, 41 Wolves mentioned there was a question about migrating REST API example to something that's using AppSync and GraphQL. What I might do is I might post a workshop that I've been building. I actually had the two living together. So this is something that Aaron and I are waking up at 4 a.m. tomorrow to do. I was complaining about it before you got on the stream, but I'm flying out. Aaron's flying it out as well, and we've got like a bit of a customer event. And it's really just like basically converting the data structures over from what you've got within a like a Lambda REST-based API call or whatever it is to your GraphQL schema. And then marrying up the behind-the-scenes data source to that. So that's kind of like the level of effort that you need. But they can live comfortably together as well. So if you've got a old school, I wouldn't really call it old school, but if you've got a solution that's been around for some time and you want to kind of mix it up with some GraphQL in terms of a new database and a new schema,
Soap would be old
mix
school.
the two. Yeah. Oh well, soap. Yeah. Soap's even. Yeah.
I had a project the other day where I had to convert soap, so not happy. That's too old school for me.
Yeah. One more example. Shall we do it? What does the audience think? Navi's got one more trick up her sleeve.
we didn't talk about throttling, right? So sometimes I want to monetize my APIs. So what I have done here is created some API keys for one of the customers. And if they don't use the key, they won't be able to hit my API URL. With this API key, I've also added a usage plan to say this company, they only get, because they're on bronze plan, not on gold or platinum, they only get 4 requests per second. And out of these 4 requests, 2 burst. So there's a rate and a burst. Rate is how many they can do in a second, and burst is how many they can do in 1 millisecond of that second. So if they send 2 requests in the first millisecond, for the rest of the second, they only get to send 2 more requests. And usually the rate on the API gateway on your account, it's per region, it'll be 10,000 requests per second. And out of that, 5,000 is the default burst rate. So first millisecond, if someone hit 5,000 times, the rest of the second, the only 5,000 requests will be entertained. But in this case, we have got only 2. And this, I want to see how many he has already used, this particular developer. So I can go to API keys. I can check the usage. 3 requests made on 20th. And I can give them an extension if I have to, but they still have 3 remaining requests. So that's good enough. I'm just going to become that developer now in my Postman using the...
I was going to say, this makes me think of like Code with Sean building a SaaS application, right? So he was talking about that earlier in the chat. I think for certain services you might want the like in terms of rate limiting. I'm always of the view I don't really want to do that to people, right? But there are times where it kind of makes sense. And if we talk about like a SaaS application that you're building, there might be like a preference that you want to give like certain users, like you exampled with bronze, right?
So I can add to that, like, yes, I agree in terms of rate limiting and stuff, but even just using the usage plan for the key itself, as a SaaS application, we do multi-tenancy at the data plane by understanding who is making the request using that API key from the usage plan. And then we can actually use that to, pull tenant configuration, or even that tenant configuration could be sharding of, different databases, or it could be completely different tables per customer, all based off of that usage plan. So it's a really great way of helping build out multi-tenanted SaaS applications.
Yeah, we even use it for internal things in AWS, right? Like we have preference to what platforms have the capability to make non-rate limited calls. versus other platforms that have rate limiting applied on them, and it's all around dealing with the internal scale of Amazon as well. So these aren't customer tools. We wouldn't do that for customer tools, but we do it for a lot of the tools where we know that there's like hundreds of thousands of people that are going to be using this day to day, but certain people need to have things run very very quickly, and others it's not so important that they get the data back fast.
Yes,
Yeah.
exactly. So per customer base, we can set up the throttling and rate limiting in the API gateway. So this person has been only given 3. After the 3 requests, even if they supply the right valid API key, it won't work. So yeah, it's like for monetizing plus for um, the protection as well. You don't want just one IP address to hit your API and others are still queuing. All right, so that's it from me.
Excellent, and I think Paul's had to jump, so we'll catch him next week. Thanks, Navi, for taking us through API Gateway and Lambda. I learned quite a bit today as well because I generally fall on the GraphQL AppSync camp, and every time I've done Lambda, I've actually used Chalice. So call out to Chalice if there's any Pythonistas that want to build a application really fast, and call out to everyone that loves SAM as well if you're building with JavaScript. But this level of like detail on API Gateway is usually abstracted away from me. So I'm really grateful to have you and your expertise on the session. And thanks, Aaron, for joining. And we will catch everyone next week. I'm not too sure what's in store, but I'm sure it's going to be a good episode. I'll have to have a look up later. So we'll catch everyone same time next week, and enjoy your weeks, everyone. Thanks, everyone.
Thanks,
Bye.
Navi. Bye, everyone.
Thanks, Navi, again.